All right, it's time to get started again. So here we go. As I look at just a little bit of housekeeping, we're going to do a video on this, just housekeeping, finishing up stuff from last week, and then I'll do a couple of videos for each day of week 2 material. So first off is the homework. And just as a reminder, I did send out an email today just to make sure everybody's aware of a few things. The first one being that everything is always due the Monday after I assign it, unless I tell you otherwise. And by the Monday after, I mean by 11:59 p.m. on the Monday after. So you should be able to find this in your email. Number 2, you should try to make all your subject lines be Math 372 and then whatever you want to talk about, so that I know who you are and what class you are in. Especially a few of you are in more than one of my classes, so if you can verify in the subject line which class you're talking about, that would be helpful. Also, as I stated before, once I print your assignments out, if you have attached documents, maybe PDF, maybe .doc, once I print those things, they are no longer associated with your email address. So therefore, please, 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 please write your name on the assignment somewhere. You could type it at the top in the header or whatever, but please do that. A couple of you have asked me questions about how to submit your homework to me. You can either just shoot me emails. Again, they need to be .docs or .pdfs. Or you can drop things into the submission folder in D2L. So either of those is okay. The D2L submission folders are just individual. Just each of you has your own, so nobody else will see whatever you drop in there. Right here, I mentioned the scanner thing. So if you're having problems making things into .pdfs, especially stuff that you've already written on, then please just go ahead and get a scanner or get a scan app. Somebody told me today that iScanner is a good one, as well as the Cam Scanner. So the idea being, again, that I'm looking for clean pages, because if I print it and it has a lot of black ink all over it, then it becomes difficult to write on top of, difficult to scan back in. You get a lot of stuff. It's just a waste of ink, all that kind of stuff. Okay. And then I sent you a list of all the stuff that it was homework that was due today, including the algebraic habits of mind questions. So make sure you know what you were supposed to turn in today, please. All right. Housekeeping item number 2, exam number 1. I know we just started, but we need to look ahead a little bit. Exam number 1 is scheduled during the 5th week. And what I intend to do for you guys is when an exam is scheduled during a week, I will open it up by that Monday at whatever testing center will have copies and so on. And you will have through that Friday to go and take your exam. So that means anytime, here's the agenda on the back of your syllabus. Okay, week 5 is September 24th through September 28th. So anytime during that week, you can take your exam. The trick to that is that I need to know during week 4 where you intend to take your exam. So that's actually coming up rather quickly, because this is week 2. So this is your deadline for testing verification. So to let me know where you're going to be taking your test, to make sure you've already got an appointment set up with them, and so on and so forth. So if you're in Commerce, you are welcome to use the Academic Testing Center. It's on the 3rd floor of Ferguson, room 308, which is the social science building with the auditorium. You do not set appointments with them. You just walk in, so make sure to give yourself time, just in case they're extra busy. They don't have that many seats available. But I need to know during week 4 if you're going to take it in Commerce, so that I can give them enough copies, and it can be there Monday morning when you go to take your exam. So if I don't know during week 4 that you need a test, then there may not be one with your name on it waiting for you over there. So be sure to let me know during week 4. Now, if you're not coming to Commerce, if you're somewhere else, it's important for me to know that. Because again, you're supposed to be taking your exams at a proctored testing environment, and that means that it should be one that's been verified through us. We do have a list. A couple of you have said, I don't know where a testing center is near me. So I am currently in the process, hopefully I'll get this done in the next day or two, of compiling our testing center lists. The problem is that 3 or 4 different faculty members in the department have a different testing list, so I want to combine those as much as possible so that you're not having to look at 3 or 4 different tests. So I'm working on that. I'll try to get it out to you in an email, and in the next couple of days it'll just be a list of all the sites. For instance, I know that if you're near Eastfield, they have a testing center. Again, if you go with them, a lot of those places will require an appointment. So please check what their policies are. And if you're not one of their students, a lot of them will charge you a fee. Normally it's about $20 or $25 a test. So it could end up being worth your while to come to Commerce, because you're going to take 2 tests and a final with me. The 3rd test, remember, is a video that you're sending me. So you don't have to schedule with a testing center for that one. But that's what's going on there. So be aware of that. Okay, last week's assignments. I just want to make sure we're all on the same page. They're due this evening, so most of you have started turning stuff in. Some of you who had questions asked me, but the question that I'm getting the most about the bubblegum factory is, what does necessary machines mean? So, for instance, if I tell you that I want to talk about the number 20 machine, then the question is number 20 a necessary or an unnecessary machine? So hopefully you've gone through and you've kind of played with it a little bit, and you know what's going on in the bubblegum factory. It's this stretching process. So I put in a 1-inch piece of gum, and I'm trying to stretch it out so that it's 20 inches long overall. The whole stinking thing needs to be 20 inches. That's what the 20 machine would do if I put a 1-inch piece of gum in there. Now, the question becomes, what if that machine breaks down? Can I make 20 inches together of gum if the 20 machine breaks down? That would be necessary or unnecessary. If I absolutely have to have the 20 machine, then it's necessary. But if I can do it in other ways, it becomes unnecessary. So that's the definition. So let's think about it. Are there other ways that I can make 20 inches? Well, that many of you have come up with the idea of that comes down to its factors, right? So 20 is 1 times 20, or 20 is 2 times 10, or 20 is 4 times 5, right? So a lot of you have come up with, oh, I don't have to have the 20 machine. Instead, I could take my 1-inch piece of gum and run it through the 2-inch machine. That would make it 2 inches. Now I have a piece of 2-inch gum, and I can run it through the 10-inch machine, and that would take that 2 inches and make it 10 times as long. So now it would be the 20. It would be 20. So I don't need the 20 machine. It's not necessary. I don't have to have it. And by the way, the 1 machine, that's just useless, right? Because I put in a 1-inch and I get out 1 inch. So that one, we don't really need it. It's kind of repetitive. So I don't need the 20-inch machine. I could do this with a 2 or a 10, or I mean the combination of the 2-inch and a 10-inch. So then the question becomes, well, what about the 10-inch? Is the 10-inch machine necessary? Well, no, because we know what? Okay, the 10 inches could be done by 2 times 5. So again, if I was trying to get the 20-inch thing going on, I could put it in the 2, run it through there. But if the 10-inch machine suddenly wasn't available, it's broken, whatever, I can do the same thing with the 2 and the 5. So again, do I need the 4-inch machine? Hopefully you know that probably I don't by now. Instead, I could run it through the 2-inch machine twice. So there are a few machines that are indeed necessary. And the activity is asking you to try different combinations. So what if you needed I don't remember what all they were, but 26-inch piece of gum. Well, is the 26-inch machine necessary? Again, no, because I know I could do it with the 2 and the 13 if I wanted to. So there comes a process. I'm not going to spell it all out for you, but I think if you can't get it from there, maybe we need to talk. So there is a process by which you can kind of do a lot of different machines and see which ones are definitely, you can't live without this machine. For instance, I would go far enough to say that the 2-inch machine is pretty much a necessary machine. I can't make 2 inches worth of gum out of a 1-inch piece of gum any other way but to run it through the 2-inch machine. So hopefully I've got a 2-inch machine that works really well, or I've got 3 or 4 copies of the 2-inch machine so that if one breaks down, I have a spare. So think about that. Maybe that helps you along your way with the bubble gum if you're not there yet. If you are there, and maybe that just helps solidify everything. Okay, and then the other thing was the locker problem. I know I threw you under the bus with that one. I just sent you out. I said, just show me what you can do. So hopefully some of your answers were to go and look in the book. I think I told you this was in the book on page 10. I'm pretty sure I told you. There's my lockers. And in fact, in the book, if you look really closely, they say right here, maybe instead of doing the 1,000 lockers or whatever it was, maybe we should just do numbers 1 to 20. So that's working a simpler problem. If you had us for like Math 350, 351, you should have seen that before. So working a simpler problem, only using numbers 1 through 20, see if you can come up with a pattern. And if you look through it, look through this book, read pages 10 and 11. Okay, you should have been reading chapter 1 by now. So if you look through there, you can see that they say right in here, lockers number 12, 18, and 20 were touched the most often, or they were changed, their status was changed the most often. So then it becomes a matter of, well, what the heck do 12, 18, and 20 have in common? So again, hopefully you've read. Let's talk about the 18 locker number 18. And let's clarify some stuff on that. Let's talk about what's happening as I'm opening and closing. And again, I think most of you have come down to, we're talking about factors here, what numbers divide evenly and that kind of thing. So let's kind of look at it. The factors of 18 are 1, 2, 3, not 4, not 5, but 6, 9, and 18. Okay. And there's a special name for 18, the kind of number that it is. It's a composite number. It is not a prime number. And you know that it's not prime because it has other factors other than 1 in itself that go into it, right? So that's the definition of prime. We'll get into that in a little bit. Okay, so I'm actually looking and I say, hey, look right here. Not only is it not prime, it's composite, but it also has like pairs of numbers that multiply together to give me that. So I've kind of marked it like I'm pairing those guys up. So in other words, we know that if we're looking at locker number 18 and person number 2, let's see, number 1 opened it, number 2 is going to close it. Well, I know both of those have a pair, right? So 2 is paired with number 9. So it's probably not going to stay just closed. We're going to have to touch it some, right? And 1 is paired with 18. 3 is also paired with 6. So going through the process, open, closed, open, closed, open, closed, right? So anything that has, I'm going to be very specific here, 6 factors, if it has 6 factors, then it's going to be closed, okay? It changed the most times. So I'm going to put out here 18 has 6 factors. But the question is, does it have to be 6 factors? Could it not be a different number? So what do you think happens whenever it has 4 factors? Well, this one doesn't have 4 factors, but there are numbers that have 4 factors. The whole point being that it's open, closed, right? So if it's got an even number of factors, that's where maybe you should be headed with this. Even number of factors. Those guys are closed, whereas an odd number of factors means that those are open. Okay, so then the question became, if you looked at it, which ones had an odd number of factors? That's basically what you were trying to figure out, right? So which ones had an odd number of factors? And the answer becomes, okay, hang on. That means it doesn't have this pairing off thing going on, right? So if it doesn't have this pairing off thing, that's where we came up with, hey, locker number, I'm going to pick on 9. Locker number 9 doesn't have that pairing off thing so much. It has it a little bit, but not completely. So we know it's 1, 1 and none, and then 3, and 3 is times itself, right? Because it's 3 times 3 gives me 9, or 3 squared. So if I was doing that pairing off thing, I see, oh, the 1 pairs with the 9 quite nicely, but the 3, he kind of stands by himself. And the reason for that, we know now, is because this was a perfect square. And I know when we ended last week, we had used the word perfect square, but now we know not only is it a perfect square, but, by the way, that means that it has an odd number of factors. So, kind of an interesting thing for me. A lot of times when we talk about perfect squares, we go for the guys who's a perfect square of a prime number. But just to be on the safe side, let's talk about locker number 81. So my question becomes, do all of the perfect squares have 3 lockers or 3 openings and closings? And the answer becomes no, because 81 should tell us about it. So 81 is divisible by 1 and 3 and 9. Oh, 9 is the guy that works by himself, right? Because 9 times 9 is 81. And then the pairing up would be 27 goes with the 3 and 81 goes with the 1, right? Okay, so that's kind of the idea. Oh my goodness, 81 has 5 factors. It's still an odd number of factors, so it still works right up here for us, and it means that it's still an open locker, right? Open, closed, open. So it'll still be an open. It's still a perfect square, but the difference being that the square root of 81 is not a prime number. So a lot of times people kind of go, oh, 1 squared, 2 squared, 4 squared, 3 squared, 5 squared, 6 squared. Sorry, I got off there. But anyway, people sometimes do that. But don't forget, like 6 squared is not going to have 3 terms, right? It's 36. So even though 36 has an odd number of factors, 36 is actually what we call abundant. It has a lot of factors. So if you're not sure about it, if you didn't look at it, go back and look at locker number 36. I'm not going to do it with you. But I'm telling you it's called abundant because it has a lot of factors in there. So go look at that and see how many factors do you have. 36. All right. So just real quickly, in your book on pages 10 and 11, I started to say they have something that's called V of N. And here they're using the Greek letter. So that's really the word is nu of N, N-U. Read up on that, and when you look at that, you say, hey, this tells me the number of factors that each number has. So that means that I'm putting in, let's pick one that we have right here. Let's pick 81. I'm putting in a particular number. Here I'm saying V or new of 81. And how many factors does 81 have? Well, it's actually pretty easy for me to count because I have it right here. 5 of them, right? So that's fairly easy. But when I really get to looking at it, I say, oh my, what about if it was new of 36? I told you guys to look at that one. So you guys figure out what new of 36 would be. So the input here is whatever number I want to, I'm out of space, I'm sorry. Let me pull another sheet of paper up. The input here is whatever number I want to know how many factors it has. Input for new. Number we want to know how many factors. So that means the output, what I'm getting out here, in this case the 5, represents what? The output for V of n is the actual number of factors, right? For a given number. Now, interestingly enough, they're not all going to be unique. So in other words, 9 has 3 factors. So V of 9 would be 3. But also we know 4 has 3 factors because V of 4 is 3. 1, 2, and 4, right? So that doesn't mean that the output is a unique number. It just means that we can kind of play with it and see what they are. Interesting factoid here. I can do this backwards. So read in your book, see what it has to say. So I can say, hey, I know a number that has, let's just use 5 because we've got it sitting right here. I know a number who has 5 factors. You tell me what number it is. Interestingly, you could tell me 81 or you could tell me other numbers. So everybody think about it. Can you find a number n, we're going to call it n, whose V of n or new of n equals 5. And of course you can't use 81 because we already talked about him. So see if you can find another number who has the same number of factors as 81, and think about what I said a minute ago about what I know about 81. It's an odd number of factors and something else was going on in there. So see if you can figure that out and see what's going on. For sure, we know that there's a lot of math going on in here. If you really look at this new function, or the V of n function, you'll see that there's a lot of algebraic habits of mind going on in there. Remember we talked about that last time. We'll talk about it again this week. So one of those things was the doing and undoing. So can I do doing and undoing? Well, I just talked about that, right? Here would be an undoing of the new of 81 that we just talked about. Okay, so there is some doing and undoing. There's also, if you read in your book, and you really need to kind of develop this, there's a way to figure out what the pattern is, right? Because if I'm sitting here thinking, so I want to know the pattern, I want to put a rule to this function. So if I'm sitting here thinking, hey, how many factors does 1 have? So I'm going to put right here a little table, so to speak. Here's n, here's new of n. And what if it was 1? How many factors? Well, we already said he's the weirdo, by the way. 1 only has 1 factor, right? So you can't even call him prime. He is not prime. He is neither prime nor composite. And the reason why he is neither is because he only has 1 factor. The definition of a prime is that a prime number has exactly 2 factors. has exactly 2 factors, 1 in itself. And 1 doesn't count there because 1 is itself, so it only has 1 factor. So it's kind of an interesting little factoid there. Okay, but 2, we know that's prime, it has 2 factors. 3 has 2 factors. 4, I said a second ago, had 3 factors. 5, again, is prime, it has 2. 6, let's think about 6. 1 and 6, 2 and 3, so it has 4. And then 7 is prime, it has 2. 8, 1, 2, 4, and 8, it has 4. But then 9 had 3. So it's just a little bit hard to tell what the heck's going on with this function. So it would be nice if we could get a function, get a pattern going on here. And that is exactly where we're going to head soon, is how we find patterns whenever we're dealing with stuff like this. So that's going to be this week. So start thinking about it and go on to video number 1 for day number 1. So how do you find this pattern? Let's not call it a pattern. Let's call it a rule. How do you find a rule to go with V of n? It's going to be part of your homework. I'm going to let you think about it and read in the book. All right.